Howdy Intro Geology students. This is our first experimental screencast. I'm going to record the screen here as I go through homework number 5. Hopefully this will give you an idea of where some of the little flaws are that trip people up and I don't know, speed things along for you. So here we are at the Intro Geology Blackboard website, and I'm going to click on homework number 5. You see that brings us into the homework 5 page. One of the first things I want to do is make sure I write down somewhere our class code 923632. We're going to need that later on. And I'm going to click then on Virtual Courseware Earthquake. And this takes us into a new web page. Now before I did anything else, actually, one of the first things that I did was I turned off my pop-up blocker. What I did was not turn off my pop-up blocker, but I allowed pop-ups from this particular site. So make sure you do that before you go any further if you haven't done so already. Within the Welcome to Virtual Earthquake screen here, you see we've got our main activities demonstration, travel time, epicenter, and magnitude. I encourage you to take some time to do the demonstration. It should help you through this. I'm going to go right to the travel time exercise though myself. And you see we've opened up a brand new window here. Read everything carefully. I'm going to just move ahead for the sake of time. Start this exercise. And this is going to start loading into a smaller window, so I'm going to just change the window size here and I'll be right back with you. Okay, one of the first things we're going to do now is close this window that's come up while it's been loading. And that brings us back to the main window that we're going to do most of our work in. And the very first thing we're going to do is we're going to go up here to drag the stations on the map to trigger the explosion. First thing we do is we're going to lay out our seismographic stations, just drag them onto the map. Ideally what we want is them to be a varying group of distances from the seismic source. And so I'm going to lay them out here. And then we're going to go ahead and trigger the explosion. Ooh, that was exciting, wasn't it? Okay, the next thing we want to do is we want to measure the SP times and distances in the data table. Here's station number 1, and to measure the time we simply drag from the P wave first arrival to the S wave first arrival. You can see that's 38.4 seconds, and this was station number 1, so we record that information here. 38.4 seconds. Moving on to station number 2, and we drag here. Station number 2 was somewhat closer to the seismic source, so it's going to be a shorter time there, 20.1 seconds in this case. We're going to go on to the other stations and drag for each of them, and that was 29.6 seconds. Station number 4. This is closer still, 18.8 seconds. And finally station number 5. This one should be quite distant. And we have a longer travel time as a consequence. 38.2 seconds. Almost the same as station number 1. Okay, the next thing that I want to do is I want to find the distances to the stations. This was done with this module right here, and we simply drag this circle out until we encounter each of the stations. It looks like station 4 is my closest station, and the distance there is 185 kilometers. Then I drag a little bit further, station number 2, and I'm picking just about the middle of the station here. Station number 2 is 197 kilometers. We keep on dragging. Station number 3 is 292 kilometers. And these last two stations are going to be almost the same distance. Station 5 is slightly closer, and we've got 372 kilometers. And finally station number 1, let's say 377 kilometers. Okay, we've done those two things. The next thing we want to do is plot these points on a graph. And so here is station number 1. 377 kilometers, 38.4 seconds. You see, as we drag it over the graph, we start getting numbers here. So we want 377 kilometers and 38.4 seconds. Look at that. It comes up right there. Make sure you drag these to the accurate spots. 197 kilometers, 20.1 seconds. 197, 20.1. That's good. And 292, 29.6. 292, 29.6 right there. 185, 18.8. 185. Come on. And 18.8. And finally the last one here, 372, 38.2. That's very close. 372, 38.2. We want to verify these points, and it tells us that we're okay. We still need to do a couple of things. We need to enter the data in the journal. Well, we've actually entered the data in the journal. We need to enter a little bit more information there, so let's go ahead and do that. I forgot to put my name in here, so I've got my name in here. And if I actually drag down here, this is something I missed the first time, I'm going to verify that my data is in the table. And now it tells me I still have 2 more things to do. I'm going to fit a line to the points using the fit line tool, and then answer the 2 questions at the end of the journal. So let's OK that box. Go ahead and fit this line. Here's the line. All we got to do is drag it over our points. Do our best job to fit the points. Minimize the sum of the squares there. Verify the slope. That's a reasonable fit. We can move on and answer the 2 questions. And those 2 questions are at the very bottom of the data table here. In order to answer those questions, I'm going to need to go back to look at that travel time curve that we just looked at. And I'm going to simply drag this out. It asks for what's the distance that corresponds to the SP lag time of 32.3 seconds. So I'm going to drag this up to 32.3 seconds. 32.3 seconds, and look, I've got a distance of 313 kilometers. And then 163 kilometers from the epicenter, well, that would be back here, 163 kilometers. That would be a distance or a time lag of 16.8 seconds. You go ahead and verify those answers. Woohoo! We're both correct. So we've completed this part of the exercise and we're ready to move on. Okay, it's a good idea to save your work at this point. And that box popped up over on the other side there, so let me just show you what that box looks like. Save your session and save this to your computer. Just OK that and save that wherever. Yeah. Yes, I saved it and it's recorded. Okay. That's the end of part 1. If you had any questions, you could certainly use the tutorials here. You can print your work if you want to, but nothing is required that you do here. And finally, we're going to quit right now and move on to the next part. Okay, at this point, we've completed the travel time exercise. I've come back to the main virtual earthquake window here. And the next thing we're going to do is go out and do the epicenter and magnitude determination. Okay, you see this has spawned a new pop-up window. And so the very first thing we're going to do here, once we enjoy the cute little animations, is start activity. And you see it's spawned the same pop-up window, and we're going to close that window and see what's behind this. And let's see, we're going to go ahead on through this exercise, but I got to shrink the window down, so I'll be back with you in a second. Okay, we're moving on with the epicenter location and Richter magnitude, and we've got a new small screen here. The very first thing we're going to do is we're going to choose an earthquake to work with and trigger that earthquake. Following this, you see we've got 9 seismic stations. These locations are chosen by the program. The next thing we need to do is to actually trigger the earthquake. Turn down the sound on your speakers because it's going to get loud. Yep, broke the windows, didn't it? Alright, next thing to do is to measure the SP lag times and amplitudes at 3 stations. We only need to do this for 3 different stations, so let's go ahead and start with station number 1. By the way, let's record our name here. And see, we're going to scroll down in the bottom part of the window here. Let's go ahead and start with station number 1. And our SP travel time as measured here is just about 26 seconds. Choose another station. It doesn't have to be station number 2. I'll go ahead and do station number 2 here. But you could choose any 3 stations in your network, ideally with a range of distances. So station number 2 is going to record a distance of 14.8 seconds. And finally, let's just choose a random station. 5 is too... 7 is too close. Oh, come on, give us a fun station. There we go, station number 9. That looks like it's a good distance from the quake. And recording that distance, we've got station number 9 is 45.1 seconds. Your choice of stations there, but you should try and get 3 that give you 3 different travel times. Okay, the next thing we're going to do is we're going to go up to this box here, which is our travel time curve. And this time we don't plot the travel time curve, we're using the one that they've already got for us. We're just going to drag this along in the familiar fashion and move this to the 3, let's see, we're going to try and move this along to the 3 time frames that we've got. We had 14.8 seconds. That's a distance of 144 kilometers. We're going to move out to, let's see, 26 seconds there is 253 kilometers. And on out to 45.1 seconds, that's 440 kilometers. Measuring the amplitude, we're going to do that with this graph. And here we want to start here and drag to the maximum amplitude. In this case, that's going to be about 7 millimeters here. And this was station number 9. So 7 millimeters, 7.0 if we want. Come back to our other stations. We had station number 2 previously. Now, here you can see from this window, a seismogram is going off the screen, so we have to use the scale pull down to decrease the scale on the seismograph so it fits on the screen. Here is the pull down. Let's go to 50%. Still not small enough. 25%. Nope, still not small enough. Let's go all the way down to 10%. Okay, that's good enough for our measurement. Start here, measuring up to the maximum there. For station 2, our amplitude is 126 millimeters. And finally back to station number 1. And again, our screen needs to be resized. Here I think 50%, even 75%. Nope, not 75. 50% should do. There we go. And so we start dragging, and we're going to get a maximum amplitude there of 37 millimeters. Our magnitude determination is done with this tool, and so what we're going to do here is, let's see, drag the distance in kilometers. We have, let's just choose for station number 2 for the moment here. Our distance in kilometers is 144 kilometers, and our amplitude in millimeters was 126. We don't have exactly 126, but we can pull approximately 130. And so our magnitude for that station would appear to be, measuring on the scale here, about a I'm going to say 5.35. I don't know if it'll take 2 decimal places. Let's go back to station number 1. We had a distance of 26 kilometers. Sorry, the distance. No, let me get that correct. The distance was 253 kilometers, and the amplitude there was 37 seconds, and that looks like the magnitude of 5.35. Those two are pretty consistent with each other. And finally, station number 9, what did we have? We had a distance of 440 kilometers and an amplitude of 7 millimeters, and I'm going to say that's about 5.4. Okay, so we've got our station, SP, lag time, distance in kilometers, amplitude in millimeters, and magnitude calculated for 3 different stations. Next thing we have to do is find our epicenter. And so we're going to go to this one. These are the 3 stations that we've got our data for, and we want to start dragging from each station circles that correspond to the distance to the earthquake. So station number 2 was the closest at 144 kilometer distance. Okay. Station number 1 had a distance of 253 kilometers. Guess where this earthquake is going to show up? Station number 9, and I'm betting that's going to be 440 kilometers. Look at this. Now we want to move our epicenter to that location where those circles meet. Epicenter is the point where the three circles coincide. And now we're going to go ahead and we're going to locate the latitude and the longitude of that epicenter using this map. Okay, we can see pretty clearly that that epicenter is at about a latitude of 34 degrees and I would say 34 degrees 0 minutes. The longitude here is starting from 116 degrees west, counting westward. It's about 116 and a little over 3/4 of the way. This is a measurement in degrees and minutes. So this is 116 degrees west longitude. Oh, that latitude I should have put as north, because we're north of the equator. The longitude is 116 degrees and about 3/4 of a degree, which would be 3/4 of 60 minutes, which is about 45 minutes, and that's west longitude. There are 60 minutes in 1 degree of latitude, and remember that when you're calculating these latitudes and longitudes, latitude increases to the north, longitude increases to the west. Okay? We're going to go ahead and verify our answers here. And it tells us that we've been given the certificate of completion after we take the quiz. So we're going to click here to continue and to take that quiz. I know this is not entirely in the field of view here, but we're going to go ahead and put in our name, institution, Fort Hayes, oops, location, Kansas, and our class code, which we wrote down before, and that was 923632. And we go ahead and submit this, and we verify that this information is correct. Yes, it is. And so now we're taking our quiz. I'm going to resize the screen because we've lost track of where we were at, so let me go back a little bit. Let me stop there. Okay, as soon as we've completed this and we've verified our answers, we're going to pop up a new window, and I'm going to have to just do this automatically. It says we've successfully completed the earthquake assignment. We're going to click here, and this is going to take us into the quiz. We need to enter our information here. And institution is and Hayes, Kansas. Class code, which we wrote down before, it's 923632, and submit. And this should be verified. We have the same information there, and we're going to begin to take the quiz. I'm not going to tell you how to take the quiz, so you'll have to go through and do this on your own, but I've gotten you up to this point, and you can take the quiz as many times as you need to in order to get the right answers, and I'll grade your best opportunity. So good luck. Have fun.